All right, so this is the last section in Chapter 1, and this is on temperature. And I know we've talked a little bit about temperature before. In this part, we're going to go through a little bit of the different temperature scales we use. We've previously discussed temperature when we discussed kinetic energy. We said that temperature is a measure of the average kinetic energy of a system. So, for example, if you've got a glass of water, the temperature of that water in that glass is a measure of the energy of the molecules that are moving around in the glass. The higher the temperature, the higher the kinetic energy of the molecules. The lower the temperature, the lower the kinetic energy of the molecules. So, when we're dealing with temperature, we basically see three main temperature scales. Two of those, Celsius and Kelvin, are ones we use in science, and Fahrenheit is the one that's the English unit that we use in the United States, while the rest of the world uses Celsius. A few basic things about these temperature scales. When we're dealing with Fahrenheit, and we talk about freezing and boiling point of water, in Fahrenheit, water freezes at 32 degrees Fahrenheit, and it boils at 212 degrees Fahrenheit. When we're dealing with Celsius, water freezes at 0 Celsius and boils at 100 Celsius. That's a nice 100 degree range. And for Kelvin, water freezes at 273.15, basically we say 273 Kelvin, and boils at 373.15, basically 373 Kelvin. Okay, that difference is also 100 degrees. So the nice thing about Celsius and Kelvin is that they're basically the same scale, except they're shifted by 273.15, and we'll see that here in a second. Kelvin is an absolute scale, meaning that the lowest possible temperature in Kelvin is 0 Kelvin. So absolute scales in anything mean that the lowest value on that scale is 0. So Kelvin, we're going to see a lot in science because so that we don't get negative temperatures. All right. So one other thing to notice here is that you can see for Fahrenheit and Celsius, we use the degree symbol, and for Kelvin, we don't do that. There's no degree Kelvin, it's just Kelvin. The second thing is, a lot of times you'll see Kelvin abbreviated as capital K. This book uses lowercase k, and it's got reasons for that, but I'm honestly used to capital K, so if you see capital K and it's a temperature, it's still Kelvin. Looking at the thermometers here, this just gives us how the freezing point and boiling point are related with each of the scales. This first thermometer is Fahrenheit, second one's Celsius, last one's Kelvin. And we can see the freezing point and the boiling point on each of water on each of the different scales. We can see that for Celsius and Fahrenheit, the difference between freezing point and boiling point is 100 Celsius or 100 Kelvin. So the difference between the two is simply shifting the scale by 273 or 273.15, depending on how precise you want to be. So basically, if I change my temperature by 10 degrees Celsius, that's the same thing as changing it by 10 degrees Kelvin. Right? Fahrenheit isn't quite that simple. Here are the conversions. If I have Celsius and if I have Kelvin and I want to get to Celsius, that's the conversion. If I have Celsius and I want to get to Kelvin, that's the conversion. If I have Celsius and I want to go to Fahrenheit, we use that. If I have Fahrenheit and I want to get to Celsius, we use that. We're going to do some practice ones on that. Also, if you've printed off or looked at your conversion tables, those are on the bottom right corner of it. All right, so let's do a couple of examples. In 1983, the lowest recorded temperature was recorded in Antarctica on Earth, and that was recorded as negative 89.2 degrees Celsius. What I want to do is convert that to Kelvin and Fahrenheit. So if we look at our conversion table, we have Celsius and want to get to Kelvin. So we see that temperature in Kelvin is equal to temperature in Celsius plus 273.15. So that means if I take my temperature in Celsius, which is negative 89.2 degrees Celsius, and I add 273.15, that's 273.15, that will give me my temperature in Kelvin. So if I do that quickly on my calculator here, I get 183.95 Kelvin. But if we're doing significant figures, we can see this is an addition problem. I've got one number after the decimal here and two after the decimal here. My answer should have one after the decimal. So if I look at that, the number after that number is 5, so I need to round up. So this would be 184.0 Kelvin. So negative 89.2 Celsius is equal to 184.0 Kelvin. Now, if I want to convert this Celsius value to Fahrenheit, I can look at my sheet, and the temperature in Fahrenheit when I have Celsius is 9/5 times my temperature in Celsius plus 32. So my temperature in degrees Fahrenheit is equal to 9/5 times my temperature in Celsius, which is negative 89.2 degrees Celsius. There. And then I add 32. So I do this multiplication first, and then I do the addition. So 89.2 times 9 divided by 5, that's 9/5, plus 32. That 32 is an exact value. So I get negative 128.56. So the 9 degrees Fahrenheit, the 9/5 is exact. So I got three significant figures here. And when I multiply, I should have three significant figures at the end. And this is addition. And 32 is exact. So my number in the end should have three significant figures. So it should be negative 129 degrees Fahrenheit. So negative 89.2 degrees Celsius is equal to 184.0 Kelvin and negative 129 degrees Fahrenheit. Okay. Example 2, on average, the normal human body temperature is 98.6 Fahrenheit. Convert to Kelvin and degrees Celsius. So in this case, I'm starting with Fahrenheit. So temperature, Kelvin. We don't have a direct conversion from Fahrenheit to Kelvin, but if we go to Celsius first, we can use that to get to Kelvin. So if I want to get to Celsius, I see that temperature in Celsius is 5/9 times my temperature in Fahrenheit minus 32. And in this case, we see our subtraction is in parentheses, so we're going to do that first and then multiply by 5/9. So I'm going to get 5/9 times my temperature in Fahrenheit, which is 98.6 minus 32. If I do that calculation, 98.6 minus 32 is 66.6. So I'm going to get 5/9 times 66.6. Remember, significant figures for addition and subtraction. We look for the minimum number after the decimal. In this case, however, 32 is exact, so it has an infinite number after the decimal, so we're going to just leave that one after the decimal. That's fine. We're going to take 66.6 and multiply by 5 ninths. So multiply by 5 and divide by 9. And we get 37.0 degrees Celsius. So 98.6 Fahrenheit for a healthy person, 37.0 degrees Celsius. Okay. Now if I want to get from Celsius to Kelvin, I see Kelvin is equal to degrees Celsius plus 273.15. So I take my 37.0 degrees Celsius plus 273.15 equals, so if I do that, I get 310.15 Kelvin. But I have one significant figure after the decimal here and 2 here, and I'm adding. So I should leave the least number after the decimal. So I need to leave 1 after the decimal. We can see that the number after 1 is 5, so I should round the 1 up. So I get 310.2 Kelvin. So average body temperature, 98.6 Fahrenheit, is equal to 37 degrees Celsius and 310.2 Kelvin. Right? That's how you use those conversions. So now you can practice a little bit. So you should pause the video right now and do these. Make sure you're comfortable with conversions in temperature conversions. And then you can come back after you've done them, unpause it, and I'm going to work through them. All right? Now that you've done them, let me run through them. So 25 degrees Celsius to Kelvin. So we can see that temperature in Kelvin is temperature in Celsius plus 273.15. So take our temperature in Kelvin, which is Celsius, which is 25, plus 273.15. That gives me 298.15 Kelvin. So I don't have any numbers after the decimal for 25, so I shouldn't have any numbers after the decimal. So 298 Kelvin. So 25 degrees Celsius is 298 Kelvin. Now this one's Kelvin to Fahrenheit. So to go Kelvin to Fahrenheit, I first have to go to Celsius. So temperature in Celsius is equal to temperature in Kelvin minus 273.15. So 603.5 minus 273.15 is equal to, so pull my calculator here. So 603.5 minus 273.15 is 330.35 degrees Celsius. Okay, sig figs, I should leave 1 after the decimal. So I should stop at 1 after the decimal. That would mean I would have 4 significant figures in this number. I'm not going to round yet because I'm not at my final answer yet, but realize that we should have stopped at that 1 after the decimal. Okay, so now I need to go to Fahrenheit. So temperature in Fahrenheit is equal to 9/5 times my temperature in Celsius plus 32. So 9/5 times the temperature I've got, 330.35. Remember, my significant figures should stop at the 3. And then I'm going to add 32 to that. So 330.35 times 9/5. So times 9 divided by 5. And then add 32 to that. I get 626 26.63 degrees Fahrenheit. I should only have 4 significant figures in the multiplication. 9/5 is exact and 32 is exact. So I should just have one number after the decimal. So 626.6 degrees Fahrenheit. So 603 Kelvin is 626.6 degrees Fahrenheit. Okay, convert -40 Fahrenheit to Celsius. So I want to go to Celsius. So temperature in Celsius is equal to 5/9 times the temperature in Fahrenheit minus 32. Remember, you do the subtraction first and then multiply by 5/9. So 5/9 -40 plus 32. So that's going to be -40 plus 32 is -8. So we're going to get 5/9 times -8. So 5/9 times -8. -8 times 5 divided by 9. 5 times 8 equals divided by 9. Oh, no, -8. 5 times -8 divided by 9 equals... What did I do here? Oh, I see what I did there. This is supposed to be minus 32. Oops. So let's fix that. So for -40 minus 32 is -72. Ha! Watch your signs. So now I've got 5/9 times -72. So let's do that. 5 times -72 and then divide by 9, which equals -40 degrees Celsius. Glad I caught that. All right, so we can see that -40 Fahrenheit, that should have been 40.0, and this should be -40.0 degrees Celsius. So I didn't put the decimal in over here either. Been a rough day. All right, so -40 Fahrenheit, -40.0 Fahrenheit is equal to -40.0 Celsius. That's the only temperature the two are going to be the same. Okay, that's where their conversions cross, right there. Right? Last one, convert Kelvin to Fahrenheit. Okay, we're going to do this again. We did that for number 2, but let's do it again. So temperature, Celsius, we have to convert to Celsius first, which is Kelvin minus 273.15. So doing that, I got 125 Kelvin minus 273.15. So 125 minus 273.15 is equal to -148.15 degrees Celsius. So here we can see that we didn't have any numbers after the decimal here. Our last significant figure was in the ones position. So that's where our answer should have it. So if we were to stop right now, it would be -148. But we're not going to round yet because we got to do another calculation. So my temperature in Fahrenheit is equal to 9/5 times my temperature in Celsius plus 32. So that means I'm going to do 9/5 times -148.15 and then add 32. So we're doing the multiplication first. So -148.15 times 9 divided by 5. That gives me negative 266.67. Degree, guess there's nothing there. Negative 266.67 plus 32. I'm going to put the answer down here. Negative 234.67. That's degrees Fahrenheit. But we're not going to leave a decimal because remember at 148 we should have stopped at 148.15. We ran out of significant figures at the 8. So that means 3 significant figures. So my answer should have 3 significant figures. So I should stop at the ones position. Negative 234.67. We should stop where the 4 is. We should round up though because there's a 6 after it. So negative 235 degrees Fahrenheit. Right? Using temperature conversions, that's how we do it. That's the end of chapter 1.